The next problem set is on area of triangles. So it's a simple formula for the area of a triangle, half times base times height. That's it. The trick for some of these problems is to find what the base and the height is. You got to use your other knowledge of triangles to be able to solve it, maybe. And one more concept that is in the lesson before this problem set was or is ratio of area of two triangles. So I think I said this in a different video, but if two triangles are similar and the similarity ratio is, let's say, x, just a number x, ratio is, again, something divided by something. So usually in these cases, you want to divide two of the similar sides, okay, the corresponding sides. So let's say that ratio is x. How the ratio of the areas is related is by x squared, and that should make sense if you think about it. For example, if we have one triangle that is double in length than another triangle, so one smaller, there's a small triangle, and there's a bigger triangle whose lengths are doubled. If you do half times base times height, you would get half times for the big triangle, if it'll be 2b times another 2b. So you can see how it's related by 2 squared, which is 4. Okay, so that's a simple recap, hopefully. With that said, let's begin with these 4 problems on this page. In the figure above, the area of right triangle ABC at 60 was the perimeter of triangle ABC. So we got to be careful to answer the question. We want the perimeter, and they give us the area. So again, area is half the base times the height. So 60 is the area, is half the base is 15. The height, let's just mark h, is length of AC, by the way. Okay, so this would be 60 divided by 15, that's 4, times 2 is 8, so h would be 8 then. Okay, now that we found this length, can we get this length, the hypotenuse? We can by the Pythagorean theorem. It'll be 18 squared plus 15 squared, and then we square root that. So 8 squared, did I say 18? 8 squared is 64, plus 15 squared is 225. This is square root of 289, sorry. Yeah, 289, which is 17, okay? So the perimeter is 8 plus 15 plus 17. And if we sum that up, that is 40. Answer is D. Okay, so here, again, as I said earlier, the formula for area of a triangle is simple. We had to find this and this in order to solve this problem to find the perimeter. Okay, so we had to use different pieces of knowledge, or one different piece of knowledge. There. Actually, I guess 2 because we need to know perimeter as well. Okay, next, in triangle ABC above, if BD was increased by 50% and AC was reduced by 50%, how would the area of ABC change? So go ahead and try this one. This is what I was saying earlier about area of similar triangles. These aren't similar anymore. This one side is increased and another side decreased. So it's not a similar triangle. But we're going to use a similar idea of what I was explaining. So the original area, so let's say A1 is half times AC times BD. That's the original, okay? Now, the new area, A2, let's say, is half. Well, this length AC was reduced by 50%, so we're going to have it. Okay? And then this length BD was increased by 50%, so we want 3BD over 2. We want to increase it by 50%, so multiply it by 1.5. Okay? So how does the area change? So let's write it. Half AC BD. This is the original area, right? So we have a 3/4 left. So this is A1 times 3/4. fourth, right? So it changed by, or A2, the new area is 3/4 A1. So it actually got smaller. Okay, so we can eliminate C, we can eliminate B. Okay, and how much did it decrease? Well, 75% is left, so it decreased by 25%. Okay. In the figure above was the area of triangle ABC. Okay, so again, this is the triangle, right? So area is half the base times the height. What is the base? It's this length here. What is that length? Well, we got to find it. We can do special triangles, 30, 69 triangle. The hypotenuse is 12, so the height of the triangle is actually 6. And over here is 6√3, and this is, because it's symmetric, 6√3 as well, okay? So the length of the base is 6√3 plus 6√3, or it's 12√3. The height is 6, okay? So this is 36√3. Yep, that's right. I'm checking my work. Okay. Figure above shows right triangle ABC and 3 squares. If the area of square region 1 is 80 square inches and the area of square region 2 is 150 square inches, which of the following is true about the area of square region 3? Okay. So, if this area is 80, how do we find the area of a square? It's just base times height, right? Or side squared, because in a square, the base and the height are equal in length. So the length of one side would just be square root of 80. So this side over here is square root of 80, and same with all 4. Similarly, square region 2 is 150 square inches in area. So the length of one side is square root of 150. Okay? Now, we can find this length. And if we find this length, we can get the area of this square. Okay? So it will just be this guy squared plus this guy squared. So 150 plus 80, how much is that? That's 230, right? So this number, this length is square root of 230. And therefore, the area of this square is 230. I didn't even need to square root it, but I was trying to finish my thoughts. Okay, and that's it for this problem set. Pretty simple, hopefully. Again, area itself is quite simple, but you need to pull in other pieces of knowledge from other lessons or units to help you a lot of the time to solve the problem, okay? As always, please like and subscribe if you found this video helpful in any way, even if you were just practicing along.